Hello students, how are you all? Now, today we have the new topic, the bonds parameters. So you know very well the covalent bonds are characterized by certain parameters such as bond length, bond angle and bond enthalpy, or sometimes it is said to be a bond energy. Okay, so they are the parameters. So now first we will discuss the bond length. So the bond length is defined as the equilibrium distance between the centers of the nuclei of two bonded atoms in a molecules. As you can see in this picture, we have a two atom. Okay, so we have one atom and other atom, so their distance of nucleus center means here is a center and here is also is a center, so the equilibrium distance between the center of nucleus, this that distance. Okay, so that distance is said to be a bond length. It is clear now? We can say that it is represented by capital R, so we can say that the capital R is equal to R A plus RB. Okay, so here capital R is the bond length and small r, A and RB are the covalent radius of the atom, said to be A and B respectively. So we can say that, in other words, the bond length is approximately the sum of the covalent radius of two atoms. Okay, and it is also measured in the angstrom and picometer also. So there is a unit, 1 angstrom is equal to 10 to the power minus 10 meter, and 1 pm picometer is equal to 10 to the power minus 12 meter. Okay, and now in other words, the covalent radius is measured approximately as the radius of an atom's core which is in contact with the core of an atom in the bonded situation. In chapter 3rd I have told you about the bond length. Okay, now on the other hands we have van der Waals radius. So van der Waals radius present the overall size of the atom, which includes its valency shell in a non-bonded situation. We can say that van der Waals radius is 1/2 of the distance between two similar adjacent atoms belonging to two nearest neighboring molecules of the same substance in a solid state. Okay, so that is the what? That is the bond length. Now we will discuss the bond angle. Okay, but before we discussing the bond length, bond angle, there is need to be study about the factor affecting of bond length. So bond length depends upon the following factors. First is bond multiplicity. Okay, what bond multiplicity? So bond length decrease with increase in bond multiplicity, means double bond, triple bond. As the bond multiplicity is increase, the bond length decrease. Okay, clear now? The size of atom. So the bond length increase with increase in the size of atom, you know very well. When the size of atom is increased, means the atomic number is increased, the bond length is also increased. Clear? Now we will discuss about the bond angle. So bond angle is also maybe defined as, you can see that the angles of the given compounds. So what is the definition of bond angles? So the average angle between the orbitals containing bonding electron pair around the central atom in a molecule. It is expressed in a degree, minute or a second. Bond angle give an idea about the distribution of orbitals around the central atom in a molecules and therefore determines the shape of a molecules. For example, we have methane molecules, water molecules and ammonia molecules. So as you can see in this picture, the H bond C bond H, the bond angle is in methane is 109.5, and as you can see in the water H2O, the HOH bond angle in H2 is 104.5 degrees centigrade, and in ammonia NH bond angle in ammonia is 107 degree. That is the bond angle. Now we have the bond enthalpy. Okay, we will discuss the third, the bond enthalpy. So I think we have learned that when a bond is formed between the atoms, energy is released. This means that the bonded atom have lesser energy than the separated individual atom. Obviously, the same amount of energy will be needed to break the bond. This is called bond dissociation enthalpy and is measure of bond strength. So bond dissociation enthalpy may be defined as the amount of energy required to break 1 mole of bonds of a particular type between the atom in the gaseous state, and it is generally expressed in terms of kilojoule mole inverse. Okay, so bond enthalpy is also depends upon two factors: the size of bonded atom. So the smaller the size of the bonded atom, stronger is the bond. So consequently, larger the value of the bond dissociation enthalpy. It is clear? When if the size of the atom is smaller, so here the bonds formed, it is stronger, so there is need to be more energy to break that particular bond. Clear now? And a bond length, shorter the bond length, larger the value of bond enthalpy. Okay, shorter the bond length, larger in the value of bond enthalpy. It's clear now? If we talk about the carbon-carbon bonds, so now carbon single bond length is 154 pm, is larger than carbon double bond, because carbon bond length is 134 pm. That consequently the bond dissociation enthalpy of carbon single bond is 433 kilojoule mole inverse, is smaller than that of carbon double bond enthalpy. that is 619 kilojoule per inverse. Okay guys, so today for enough. Thank you so much.